Right. Software define wide area network. See, nowadays everything is getting into automation. Software, meaning what is automation? Reducing the human being work. That is what automation. Instead of we doing it, software will do it for us. But we have to give software the instruction what to do. No, for that you need knowledge. Without that knowledge, you cannot tell anything to software. You need to have a knowledge of networking in depth. Only then you can make the softwares to work for us. So that's one clarity that everyone should have. Software cannot do anything by its own. Software cannot configure BGP when you tell software configure BGP. If you type BGP, will it configure? No. We need to tell with whom it should form neighbor. So it will go and form neighbor. We should tell what policy you want to have to route packet for some destination. Then accordingly software will do it. So without the knowledge, it is not possible for someone to use any software. Now here is a WAN technology application like BGP, MPLS, OSPF, VPN across the internet. See, last class we were doing DMVPN. You were doing everything by your own manually. That VPN can be done in SDWAN using an application. So those who do not want to go to CLI and form that VPN, they will do using SDWAN. Result is going to be the same. But the difference is, in the previous class, you were 100%. But here, you are only giving instruction. 90% of work will be carried out by the software. But again, the 10% is matter, very important matter. Without the 10% matter, 90% cannot be achieved. When I say 90%, I mean the manual work. The manual work is being reduced when you are getting into SD-WAN. You don't need to configure MPLS, but you need to know MPLS in order to make use of this tool SD-WAN. You need to know how BGP works to make use of this SD-WAN. Even without the knowledge of MPLS, BGP, DMVPN, people do use SD-WAN, but they are not really doing their job 100%. They simply duplicate the configuration that some knowledgeable person do. They just simply duplicate. They copy and they repeat. But in a critical environment, they will not be having confident what to apply, what to give in the SD-WAN tool. So, software-defined wide area network integration and architecture. What we are going to learn in this topic is not MPLS or BGP, or in order to use this tool, definitely you should have the knowledge. What we are going to learn is what this SD-WAN contains. That's it. When you know what it contains, with the knowledge of BGP and MPLS and other protocol like DMVPN and so on, you can go and talk to SD-WAN comfortably. You will know how to use that tool when I introduce the tool to you. So this is just introducing the tool to you. That's it. Many people say that they know everything just after learning SD-WAN tool. No, you don't know. It's just a tool. It's a tool to make your work easier. Software defined wide area network. And this is widely seen in enterprises as well as in service provider. Now this shows the evolution and their problems. Without SD-WAN, only by configuring in a traditional way, the connectivity is by MPLS only or through static configurations. Static way, meaning we only decide the routing protocol like OSPF, and the routing table will be built. To that routing table, labels will be provided, and the label switch path LSP is determined. But SD-WAN, that determines which will be a well suitable path, whether to use the broadcast link or a cell phone link or 5G link. So it can work on multiple platforms, hybrid WAN, and they all have different technology. Broadband have got different technology, LTE different technology, but here we have only MPLS in our IP network. So these SD-WAN devices are capable of using broadband, LTE. Broadband is nothing but IP, which is IP path. LTE 5G, which means the one who is doing SD-WAN should also have a knowledge of these things. Only then you can make use of those things using SD-WAN manager. So previously it was only network centric, network focused. The paths, the network. Accordingly, we enable protocols. The configurations were done manually on each device. But here it is not network centric, this is application centric. So we have an application which is monitoring multiple devices in a centralized way. Using that application, we configure our network by by creating policies using the graphical user interface. And then we push the configuration to various devices. That's what automated means here. So what I'm trying to ask here to those people who say, I know SD-WAN. When you are not able to manually configure per device, how you are going to manage effectively a tool which is going to manage your entire network in a centralized location? That's a very important question that you should ask yourself. Straight away going to SD-WAN is not really going to make anyone expert. Only those who have knowledge of how it works per device will now get a pretty good knowledge of how I can have one tool and configure devices through that tool from a centralized place. Now, application awareness. It is CLI, we manually do, so there is no application. And because we do manually, we cannot do many things at a time, so we can only provide. This is actually, I don't agree with these things. Why they are saying only you can provide basic QoS? They want to praise SDWAN and they want to curse the traditional method. I don't agree on those things. For these many years, we were having everything CLI and everything was under control. But now everything is in control of software. We don't have control. So when you have given control to software, you know what will happen. The other bigger software will read this software and it will know your patterns and it will say human being is no more needed. We know how the human being will configure because we have read the patterns of human being. So that's the actual thing that has happened. It's already gone from our control. So this is actually, these things were good. But now we all move to software defined stuff and machines now know how the human being behaves, how they configure, how they react, and now they will do by themselves. That is what actually we have done through this type of. Anyway, I am not getting into that because today's topic is SD1. Let me praise SD1 for some time. So here we got a lot of software related stuff. Applications are there, and then a lot of cloud applications are there. SD-WAN. Provisioning. We used to plan for upgradation. We used to plan for deployment. To bring up one service provider network, we used to do step by step, module by module. And in few months, your data center will be, service provider network will be ready. It won't be just in one day. But here SD-WAN says zero provisioning. Hey, you no need to do anything. Zero. You no need to touch everything. Don't worry. We will do everything for you. Software will do it. Think about this danger. They were telling this as advantage. Zero touch provisioning. You no need to even touch the device. It will get automatically up and running. You engineers no need to have brain. That's what indirect message it is conveying. That is not true. We need to have very good knowledge to control these tools. But Sarah, there are some basic things that come automatically when you use SD-WAN. Things like identifying the remote sites. You don't need to manually say form VPN with this hub device. This will auto-discover. That is what here they mean. It will auto-discover the SD-WAN components like remote site, edge device, etc. So a few days only it will take, not months, because most of the load of our engineers are taken care by the software. The traditional method took some months. This modern method SD-WAN takes days, or zero touch provisioning. Business driven for SD-WAN, or in what way SD-WAN is better for an enterprises? It reduces cost. What cost? You don't need to have too many people. And there is a software which is monitoring a big network which a single human being cannot do. So when a software monitors all the devices, it knows where the devices are not well used. So it will go and use those areas. In that way, the performance gets improved. Optimizing cost and improving performance for enterprises. Reduces MPLS dependency by leveraging low-cost bandwidth and LTE 5G circuits for non-critical traffics. See, this LTE 5G, these are all radio waves technology. The segment routing can also use those technology along with the IP. We are from IP world. So what it says is you don't need to only depend on IP/MPLS. You will be able to make use of the telephone circuits, the radio technology to transfer data. Traditionally, what we used to do is we used to take the radio and we convert into IP. Now, these SD-WAN edge devices are capable of directly talking to radios from IP. That's what they call here as an advantage. Second is SaaS performance, that is software application. Because you use application, it makes things easier. Everything is software based. So it improves SaaS, that performance through software as service, performance through direct internet access, breakout at the branches level. So on the branch level, to access the internet, we usually go to the head office and get routed. But here, that smartness will be given to every branch office using the application. Actually, what they are trying to say is, in SD-WAN, we have something called vSmart. That is what they say indirectly here. That vSmart will push the policy right on the edge device. Next is centralized management provides a single pane of glass for monitoring and policy enforcement across the entire fabric. As I said, you may have many branch office and a head office. To manage, to monitor, to configure, you have a centralized management tool. One place you sit and you will be able to monitor, check the status, and do multiple things from one single place. Next, the deployment will take few days. That's what we saw in the previous page. It is because there is something called zero-touch provisioning. What it is, when you are adding a new site, we usually send our engineers. They go and then they plan and then they connect the device. They do the configurations for night and day. And then it comes to online. But now it is not like that. You just send the device, edge device, to your branch office, the new branch office. Someone who have got no internet knowledge, no network knowledge, can get the device, connect it to the power outlet and the internet available there. That's it. As soon as they connect the device to the power outlet and the internet, that device will find its SDWAN controllers and get added. So the SDWAN controller can be in a remote site. Maybe this new site is in Australia, the remote site may be in America. But you see, as soon as the Australia site employee plugs in the device to internet after powering it on, it gets attached to America office, head office. And then from there, all the necessary configurations get pushed. And in few minutes, the entire site-related configurations are done on the edge device. The edge device is ready now. All that you need to do now in the remote site is the LAN. You need to connect LANs to the switch and switch to the edge device for routing. See, you still have the existing network, CLI based. Only thing is the edge device that connects to the internet, you change to SD-WAN edge. Not the same old ASR router or a Juniper device. You need to have an SD-WAN edge device. And you connect your existing network to this SD-WAN device. And all the necessary configuration for that site on the edge router is pushed from the centralized location somewhere. All right, so this is what today the business expects, and that is provided through SD-WAN. Now, this SD-WAN architecture contains these 4 controllers. What is this WebTailer? In the beginning, SD-WAN was only WebTailer, SD-WAN in Cisco. Because WebTailer was the SD-WAN company which was successful, and Cisco purchased that company. And now it has become Cisco WebTailer SD-WAN. And slowly that word WebTailer is removed now. Instead of WebTailer, they put WAN. Cisco WAN SD-WAN. WAN. Cisco SD-WAN. They try to avoid the word WebTailer now. So this vManager is called as WAN Manager now. vSmart is called WAN Smart. WAN Bond, WAN Edge. Or C Edge is also one series. C Edge, Cisco Edge. Now these are the 4 controllers that we have in SD-WAN. This one is what we have it in every site. We call it as V Edge or C Edge. It is kept in every site. The hardware or the virtual router that forwards the actual user traffic between the sites. So, see, on the edge router we will have policies. Which site can talk to what all other sites. Same like DMVPN concept, spokes to spokes. This is spokes, the edge device. That needs the routing. So that routing policy is now deployed in V Edge and C Edge by a smart control plane called vSmart. So all the necessary configuration in the edge device is distributed to all the edge devices around the globe by a controller called vSmart. You need to understand the purpose of this vSmart. That is to distribute the routing policies, security policies, all that the router can do in an organization edge. For which traffic I should use MPLS tunnel, for which traffic I should send it as an IP path, IP traffic. All these are what? Control plane related stuff. Those things are configured in management plane by you and distributed to all the WAN edges by the vSmart. So vSmart is the one which talks to every edge device. Where is the edge device? In various parts of the globe. Where is this vSmart? It can be in a cloud or it can be in one or two sites in different location. Redundancy you can have. You can have more than one vSmart. Okay. The orchestration plane is nothing but vBond. What is orchestration? The device which is responsible to identify the edge device of the organization. See, there are many people, many companies using SDWAN. Our company SDWAN should not merge with some other company's edge device. Very important, right? It should not get merged with some other company's edge device. So to authenticate the edge device of this company and add it to the SDWAN fabric of this company, you need an authenticator. That is vBond. It's an authenticator. When an edge device from Australia talks to your office vBond will check whether it's a legitimate edge device. How? Using certificates provided inside, which is kept inside the Cisco device by Cisco. Digital certificate. Cisco has already put the digital certificate in it. So using that certificate, the edge device will talk to the orchestration plane, which is in somewhere in the internet cloud. It may be kept in cloud or somewhere in the US office or somewhere. So with the IP address that is provided in the edge device, it will come and talk to vBond. Hey, this is my certificate, authenticate me. vBond already knows that you will be coming with the certificate through the vManager. vManager will already push to vBond that these are all the legitimate vEdge devices certificate. So when an edge device comes to vBond with a certificate, that certificate is compared with the certificate already given by vManager, and vBond approves, accepts. After accepting, vBond only will give the information about SDWAN location and vSmart location to the edge device. So that edge device will go and get registered with the vManage and vSmart. Did you understand the story? How the SDWAN devices gets into one fabric, one frame, one fabric? Did you understand these controllers?
Partially.
Alright, let me put it in Tamil. இது எல்லாமே சிஸ்கோ டிவைஸ். விற்கும் போது சிஸ்கோ என்ன பண்ணுது, ஓகே இந்த டேட்டா பிளேன், அதாவது இந்த எட்ஜெலாம் உனக்கு நான் கொடுத்துருக்குறேன், அந்த எட்ஜினுடைய சர்டிஃபிகேட் ஒரு காப்பியை நான் வி மேனேஜரில் வச்சு கொடுக்குறேன். வி மேனேஜர் வந்து ஒரு சாஃப்ட்வேர் தான், அதில் இந்த சர்டிஃபிகேட் எல்லாம் இருக்கும் வி மேனேஜரில். இந்த வி மேனேஜரை நீங்கள் வந்து ஒரு விஎம் மிஷினில் போட்டு நீங்கள் அதை ஸ்டார்ட் பண்ணுவீங்க. வி ஸ்மார்ட்டே அந்த மாதிரி தான், ஒரு விஎம் மிஷினில் போட்டு ஸ்டார்ட் பண்ணுவீங்க. வி பாண்டையும் அந்த மாதிரி ஒரு விஎம் மிஷினில் போட்டு ஸ்டார்ட் பண்ணுவீங்க. இது மூணுமே ஹார்ட்வேர் கிடையாது, சாஃப்ட்வேர். அப்போ அந்த வி மேனேஜரில் பார்த்தீங்கன்னா அந்த SDWAN-க்கு சொந்தமான எட்ஜ் டிவைஸ் எப்படி இருக்கும், அதனுடைய சர்டிஃபிகேட் எப்படி இருக்கும்னு சிஸ்கோவே கொடுத்துட்றான். அதனுடைய ஒரு காப்பியை அந்த எட்ஜ் டிவைஸ்லையும் போட்டுடுறான். இப்போ நீங்கள் பண்ண வேண்டியதில்ல, அந்த எட்ஜ் டிவைஸை தூக்கின்னு போயிட்டு ஒவ்வொரு சைட்டில் கொடுத்துட்டு இதனுடைய ஐபி அட்ரஸ் நீங்கள் கன்ஃபிகர் பண்ணீங்களே ஒரு விஎம், இந்த விபாண்ட் சாஃப்ட்வேரை போட்டு அதனுடைய ஐபி அட்ரஸ், பப்ளிக் ஐபி அட்ரஸை விஹெச்ஜி கிட்ட கொடுப்பீங்க. உடனே அந்த விஹெச்ஜி என்ன பண்ணும், அந்த ஐபி அட்ரஸ்க்கு சர்டிஃபிகேட்டை எடுத்துகிட்டு வரும். உலகத்தில் எங்கே நீங்கள் இந்த எட்ஜ் டிவைஸை இன்ஸ்டால் பண்ணீங்கனாலும் அங்கேருந்து பிங் அடிக்கும். நீங்கள் சொல்கிற ஐபி அட்ரஸ்க்கு பிங் அடிக்கும். விபாண்ட் ஐபி அட்ரஸை நீங்கள் கொடுப்பீங்க, அதுக்கு பிங் அடிக்கும். விபாண்டு சரி வா உன் சர்டிஃபிகேட் கூட பார்க்கலாம் அப்படின்னு கேட்கும். அதுக்கு முன்னாலே விபாண்ட் என்ன பண்ணியிருக்கோம், அந்த சர்டிஃபிகேட்லாம் வி மேனேஜரில் சிஸ்கோ வச்சு கொடுத்தானே, அது எல்லாத்தையும் டவுன்லோட் பண்ணி வச்சுருக்கோம். அப்போது இவன் சர்டிஃபிகேட் கொடுக்கும்போது அதை வெரிஃபை பண்ணி மேட்ச் ஆகும்போது இந்த விபாண்ட் என்ன பண்ணுது, வி மேனேஜருடைய ஐபி அட்ரஸையும் வி ஸ்மார்ட்டோடைய ஐபி அட்ரஸையும் இவனுக்கு தெரியப்படுத்தும். அதை வச்சு இவன் டைரக்டாகவே வி ஸ்மார்ட்டோடவும் வி மேனேஜரோடவும் ரெஜிஸ்டர் பண்ணிக்கிட்டு SDWAN-ல ஒரு மெம்பராக சேர்ந்துடும். அதுக்கப்புறமா நீங்கள் என்னெல்லாம் பாலிசி இதில் போடுறீங்களோ அந்த எட்ஜிக்கு போக சொல்லி அது அங்கே போகும். அது யாரை டிஸ்ட்ரிபியூட் பண்ணுறது, வி ஸ்மார்ட். இப்போ புரிஞ்சுதா? வி ஸ்மார்ட்னுடைய வேலை டிஸ்ட்ரிபியூட் பண்ணுறது தான் அந்த கண்ட்ரோல் பிளேன் இன்ஃபர்மேஷன். ஆனால் கண்ட்ரோல் பிளேன் தேவையான கன்ஃபிகரேஷனை பண்ணுற இடம் வந்து வி ஸ்மார்ட் இல்லை, வி மேனேஜர். வி மேனேஜர் வந்து ஒரு டூலு, அந்த டூல் வழியாக தான் நம்ம கன்ஃபிகர் பண்ணுறோம். அந்த கன்ஃபிகரேஷனை அனலைஸ் பண்ணி இந்த கன்ஃபிகரேஷன் யாருக்கு, எந்த விஹெச்ஜிக்கு, ஆஸ்திரேலியாவில் இருக்கிற விஹெச்ஜிக்கா இந்தியாவில் இருக்கிற விஹெச்ஜிக்கான்றத வி ஸ்மார்ட் தான் உங்கள் கன்ஃபிகரேஷனை பேஸ் பண்ணி பிரித்து, ஓகே இது இந்தியாவுக்குரிய கன்ஃபிகரேஷன், இந்தியா ரவுட்டருக்கு விஹெச்ஜிக்கு அனுப்பலாம். இது ஆஸ்திரேலியாவுக்குரிய பாலிசி கன்ஃபிகரேஷன், இது அங்கே அனுப்பலான்ட்டு தெளிவாக அனுப்பி வைக்கிறது வி ஸ்மார்ட். அதனால தான் அது பேர் வி ஸ்மார்ட்.
ஆனா நம்ம வி மேனேஜ்ல ஒரு சைட் கிரியேட் பண்ணும்போது அதோட லொகேஷன் கொடுத்துருவோம். சைட்
வி மேனேஜர்ல சைட் கிரியேட் பண்ண மாட்டோம். வி மேனேஜர்ல எந்த சைட்டுக்கு, அதாவது இந்த விஹெச் வந்து அத்தன்டிகேட் ஆகிட்டு வி மேனேஜர்ல அப்பியர் ஆகும். அப்போ நீங்கள் கன்ஃபிகரேஷன் ஆப்ஜெக்டாக கிரியேட் பண்ணி எந்த ஆப்ஜெக்ட் எந்த விஹெச்க்கு உண்டானது அப்படின்னு மேப் பண்ணி விட்டீங்கன்னா அது வி ஸ்மார்ட்டுக்கு தெரிய வரும். அதை எடுத்துட்டு போயிட்டு அந்த விஹெச்ல கன்ஃபிகர் பண்ணி விட்டுரும். இன்னும் கேட்குறதா கேளுங்க, இன்னும் டவுட் இருந்தா கேளுங்க, தெளிவா கேளுங்க. ஓகே,
இப்போ இது ஒரு SDWAN செட்டப் கிரியேட் பண்றதுக்கு இந்த 4 இது தேவைப்படுது.
ஆமாம்.
ஓகே,
you must have one vmanage, one vbond, and you may have more than one vsmart, and you will definitely have more than one vhs. Many sites you will have. That's why you are going for SDWAN. These are the 5 building blocks of SDWAN. This is the architecture of SDWAN. Do you have time or we should stop now?
no sir, we can continue.
You can continue. Right. So, core SDWAN components. A detailed function of WebTailor, SDWAN, and also iOS XE elements. See, Cisco iOS XE, like Catalyst, they also can be a edge device. That's why they put here and iOS XE. But not all iOS XE, some version of iOS XE are capable of being an edge device. Now, vManage, what is the job of vManage? It's the Network Management Center tool. It's a GUI. Is it a hardware device? No. We install that in ESXi or AWS in cloud or Azure cloud. I just told you it's a software vManage. vSmart is the control plane controller, the smart guy who knows what routing table to put in which VH based on the configuration that you did in NMS. So, is this a software or a hardware? It's a software again, deployed in a VM machine. vBond is an orchestra. So, this is also a software. You may have NAT also. That is also taken care by vBond, NAT traversal to reach vBond. See, sometimes this vBond they may keep in private and they may do NATing on a device. Never mind, even if it comes to this device, the NATed address, it will get mapped. vBond is smart enough to accept it. See, this is also a virtual device. This clarity you should have. All these three main controllers are not physical. C-Edge, which is the Cisco's SDWAN router. It's a hardware. All these Cisco devices can be used as the edge device on the sites. See, they are not controllers. Controllers are WebTela only. But now they try to use WAN instead of VW. WAN. They don't want to mention the WebTela name as they have acquired it. But this device is Cisco itself, Cisco's manufactured device itself, the edge device. This is an edge device. See, Cisco Edge. And WebTela also have an edge device. I should say like this, Cisco also have edge device. But this is WebTela Edge from the beginning. It's Cisco's WebTela routers, like WebTela 100, WebTela 1000, 2000, 5000 series router. Why they call it as legacy? Because it's no more Cisco. So Cisco is no more encouraging this in production. They do more of this device. Very good. Cisco's Meraki, correct. That is an older version of SD-WAN with limited features. Meraki is also an SD-WAN. You can say older version of SD-WAN. This SD-WAN can do some additional thing which Meraki cannot do. Right. Now, there is an underlay, there is an overlay. Underlay can be anything. You may have a MPLS VPN connection with the ISP. See, you need to understand this is not enterprises. This is many enterprises, many remote sites. You are going to communicate via internet. That can be an MPLS, that can be an internet, means IP, that can be cellular network, that can be 5G, fifth generation. It can be any of this. You may have any of this subscribed as an underlay. This is underlay. Underlay means the subscribed WAN connection. Using this, according to the policy, if it is needed to have a MPLS, SDWAN will have VPN over MPLS, that is overlay. MPLS will have VPN over MPLS. If the policy matches with LTE, then VPN, the overlay will be using LTE. See, you can reach from A to B, C and D and E using all this technology, right? Provided by internet. Now, overlay is, the tunnel is going to be formed according to what policy you have written to communicate between A and D. To communicate between A and D, if your policy says use internet, then the overlay will be formed using internet connection. If policy between B and C is using LTE, then using that LTE connection, it will form overlay tunnel. That's what it means. So we have two things here, underlay and overlay. One is physical network connectivity. Another one is virtual network connectivity. According to the policy, the tunnel gets established. Using the tunnel, the traffic is going to be forwarded. Yeah. So, underlay can be all of this or any two of this or any one of this. Physical transport, that's what underlay, the physical. Basically, it provides the reachability between the sites. It can be using MPLS or internet or an AND LTE or an AND 5G, depending on what your company has subscribed. SDWAN fabric is nothing but a logic that connects the underlay to the overlay. SDWAN provides you a VPN, to make it very clear, provides you a VPN using the physical connectivity, but you have too many, 1, 2, 3, 4 physical connectivity. Which one? According to your policy. Based on the policy, see the word managing. Managing means something is controlled, whether to go via MPLS or to go via IP, managed transport. And you can also have IPsec for the traffic using SDWAN. So it can also provide security. See, the tunnel that is formed, the tunnel which is providing you a virtual pipe connection, is a secure tunnel. Now, what does this carry inside the tunnel? That vSmart, no, the vSmart. That is the one which is using this routing protocol called OMP. OMP stands for Overlay Management Protocol. So this is like a OSPF routing protocol. This is the protocol that is distributing the route information to all the sites, so that the edge router dynamically learns the route in the routing table. What protocol? Not OSPF. It is OMP. OMP is the one which carries the routes, which need to be configured on the edge device according to the policy that you have mentioned on the vManage. The routes are formed according to the policy that you have mentioned in the vManage. vManage is an application. So whatever the application says, vSmart creates the route information and pushes to the necessary appropriate edge device so that they will form a route in the routing table and packets get forwarded. Zero touch provisioning, very interesting. I already told you what it is, but I am going to tell you in detail now. I told you there is one new site coming in Australia, right? Assume. And your head office is in USA. Where is the V bond? USA. Where is the new site? Opposite, totally another extreme. If USA is in east, this is totally in west end of the world. There you are providing power to the device. And device gets the IP address by the DHCP of the Australia network and also the DNS server IP address. Why? It has to resolve the cisco.com. It has to go to cisco.com now, which is inbuilt configured. I told you it will go directly to vBond. No, not exactly. It actually goes to cisco.com using the DNS. It resolves the IP address of cisco.com. Now, from there it gets the certificate from the cisco.com. If the certificate is not already kept in the vEdge, Cisco usually sends with certificate in case. I'm just telling you why DNS server. It needs to resolve the domain names. So in case if the certificate is not available, the WAN edge will go with the serial number and get the certificate downloaded from Cisco site automatically. Cisco knows their product. They have already registered the product before selling. So when the request comes, it will give the certificate. So now, the device uses the DNS to resolve the vBond orchestrator address to start authentication. Now, vBond orchestrator address can also be configured using domain name. You don't need to give the IP address of the vBond. You can provide a domain name, dersh.net, dersh_vbond.net, and you will have the IP address of the domain. So whenever this vEdge looks for the dersh_vbond.net, the IP address will be resolved by DNS server. Using the IP address, it goes to the vBond for authentication. Now, the certificate is validated via Cisco plug and play and SDWAN hardware chip, which is there in the vEdge. The vEdge, the chip has got the certificate in it, and that certificate is now verified. See, the device downloads the configuration. Okay, before that, even the vBond downloads the certificate from vManage, compares it. That's what actually happening here. Once the authentication is done, that WAN edge device gets the IP address of the vManage and vSmart, goes and registers with the vManage and vSmart, after which the edge device will download all the configurations and the policies which are already configured by you and kept for Australia office. That becomes now the fabric, part of fabric, SDWAN fabric, SDWAN, your global SDWAN network. I repeat, you on the device. Device gets the IP address so that it can talk to the internet and the DNS server address from your local DHCP. With the help of that, it goes and talks to the necessary domains to get the certificate first. After getting the certificate, it goes to the vBond with the domain name of the vBond if provided. Again, it depends on the DNS to resolve the domain name into IP address. So using that IP address, it goes to vBond and the initiation of authentication starts. Once the certification is validated with Cisco PNP, which is there in the hardware chips, the device becomes now the member of the SDWAN fabric, which you have already in place. Any question? Did you understand how the onboarding of a new device happens with the existing fabric that is available?
Yes.
Okay. Control plane bringing up sequence. What is control plane? The routing table of edge device. All the edge device needs routing table. Yeah, all the edge device needs routing table. The routing table, you are not going to configure on every edge device on every site. So what happens, when you have a network already existing, the traditional network with some network, some LAN networks, this edge device, once it becomes a part of SD-WAN, it will advertise all this information to the vSmart. Likewise, every site will advertise. Now, vSmart knows what all internal network you have. Now, you have a vManage saying who all can talk to whom. Should they use MPLS or should they use IP? Do they need a security IPsec? All those you configure. Now, this guy, knowing all the sites and their network very clearly, according to what has been configured as a policy in vManage, decides what networks of this to be given to the router here so that it can reach. What all should be given, what all should be filtered will be determined by the vSmart according to the policy that you put here. See how interesting it is. இவனுக்கு எல்லா லேண்ட்ல இருக்கிற ரிமோட் சைட்ல இருக்கிற அத்தனை நெட்வொர்க் தெளிவா தெரியும். எல்லாத்தையும் இவங்கிட்ட இருக்கிற எல்லாத்தையும் தூக்கி இவங்கிட்ட கொடுத்துடாது. எப்படி கொடுக்கும்னா, vManage என்னெல்லாம் கொடுக்கலான்னு பாலிசியில சொல்லி இருக்கிறீங்களோ vManageல அந்த ரூல்ஸை மட்டும் இந்த சைட்ல இருந்து வர அட்வர்டைஸ்மெண்ட்ல எடுத்து இவனுக்கு கொடுக்கும். ஸோ தட் அந்த பாலிசிக்கு ஏற்ற மாதிரி தான் இவன் பிங் பண்ண முடியும். இஷ்டத்துக்கும் எல்லாரும் எல்லாத்தோடும் பிங் பண்ண முடியாது. அதுதான் இங்க பார்க்க போறோம். Initial contact. V-edge and C-edge reaches out to V-bond. எதுக்கு நமக்கு தெரியும், authenticationக்கு. That is step 1. V-edge and C-edge reaches to V-bond for authentication to become a part of the SD-WAN. V-bond validates the device certificate And then after validation, it provides the IP address of vSmart and vManage. So it needs to know no, the location of vSmart to get the control plane. So after authentication, vBond will provide that so that it can go. Now OMP is the routing protocol I told you, which is used between the vEdge and vSmart. So a secure DTLS and TLS. This is connection oriented transport layer security. This is datagram transport layer security. But it's a secured one. Using this, a session is built to vSmart. vSmart and who? vSmart and vEdge. And OMP session is initiated. OMP session means the control plane session is initiated. And then IPsec tunnels are established between the edge sites based on the vSmart route advertisement. So who is giving the control plane information? It is a vSmart using the OMP. After receiving the route information from one site to another site, how they will talk? They will talk using IPsec. See, that's one button you need to click. I want IPsec. That's it. IPsec will be enabled. Is this clear?
Yes, sir.
Okay. Now about this routing protocol, the vSmart protocol, which is distributing the control plane information. Unified protocol. OMP acts as the SDWAN protocol, which is equal to BGP. Like BGP advertises the network with attributes, OMP also advertises network with attribute. What do they carry? They not only carry the route, they also carry the attribute like transport locator and the service information. Should I use MPLS? Should I use IP? Should I use 5G? And the transport locator, to which location I need to transport. The route information with the neighbor with which it has to give the route information. Neighbor discovery kind of thing, according to the policy. So OMP is a protocol which is equal to BGP. OMP is the protocol of SDWAN. That is to carry the route information with TLOG, transport locator. I'll be teaching you what is transport locator in detail in coming slides. And the service informations like MPLS, IP, 5G, etc. Centralized control. I told you this is the protocol of the vSmart, the centralized controller. Not vManage, vSmart. vManage is the place where you configure things using GUI. But vSmart is the one which is interpreting your GUI configuration into CLI, into necessary commands. Now, the centralized controller, it replaces the traditional per hop BGP peering in the overlay with a hub and spoke model of vSmart. So what becomes a hub? vSmart becomes a hub. All the vEdge becomes a source. That's why I was teaching you DMVPN before I brought you here. I told you the NHRP in the DMVPN, the table is given by the hub. And traffic is not always going through the hub. Likewise, vSmart is not through which the traffic will go. vSmart will only provide the route information according to the policy to the WAN edge. WAN edge only will forward according to the route given. So vSmarts are like hub. You can have one or more hub like we had in yesterday's lab in DMVPN. But the all the spokes are V edges. Rich metadata. So this OMP, what it carries? It carries all the attributes that is attached to the network called transport locator, color. We call this TLOC colors, the attributes. More detail is coming. Site ID. Every site will have an ID. Like Australia site will be given an ID. Many sites, if you have to identify the sites, you will have site ID. Like a router ID in OSPF, here you have site ID to identify the sites. A site may have one or more edge device. VPN table for the segmentation, etc. What else? Fabric visibility. OMP ensures every site knows how to reach other sites according to the policy. That's what I was saying. It will not advertise all the route of one site to another site like you saw in DMVPN, We didn't have any filter there. So all the EIGRP routes of spokes 1 is available in spokes 2 and spokes 3. But here, it will control the distribution of route according to the policy. Who? vSmart, using OMP. Did you understand the role of OMP and what it is?
Yes, sir.
Now comes the transport locator, which I was told here many times, TLOC color, TLOC. Transport locator uniquely identifies the tunnel endpoint. That is transport locator. If I am in this edge, with which edge I need to form tunnel? According to where you're going, you're going from A to B. So the tunnel should be formed with B, not with this side C. How it is identified? How B is identified? With transport locator. So when the traffic goes, try to go out, tunnel gets established exactly with B because the transport locator says to go to B, this is the edge device to which you need to form association. Very nice word. Identifying tunnel endpoint in the fabric. In the fabric, you have many edge devices in various sites. But for this traffic, which edge device I should go for this destination? If I want to go to this destination, which site? Should I go to Australia site? Or should I go to India site? Or should I go to Sri Lanka site? Where should I go? Where should I go to? With whom I should form tunnel? That edge point identification is provided by TLOC. So let's start from first step. System IP you should know. TLOC uses system IP, which is a unique identifier for each edge device. Edge routers. Every router will have a IP, like a router ID in OSPF. System IP. Here we don't call it as router ID, we call it as system ID, but nothing wrong in calling as router ID or edge ID. So to remember, I'm saying it is edge ID. Edge router's IP address to identify the edge device. So that is needed now if you want to say form VPN with that edge device. How you say that edge device? With the IP only. IP of that edge device. That is system IP. Because you need to establish tunnel with one endpoint. For that you need an ID. Secondly, the color. If I want to form tunnel with that India office, I have the IP, but what should I use? This customer is having MPLS. He has got IP. He has got cellular connection. Which one should I use? That is what called as color. Should I use MPLS color? Should I use IP color? Should I use LTE color? What type of transport should I use is identified by color. At last, according to the policy, do I need to send without encryption, called GRE, or with encryption, IPsec? So the tunnel protocol by default is GRE. I told you just by enabling one tick mark, you can make it as IPsec. Did you understand now transport locator color means?
Yes, yes, sir.
Is it interesting? It should be interesting, very interesting. Yeah. So now if I take you to the back screen, you will understand this better. What does OMP carries? It carries the route information. It carries the T-log information, right? It carries the T-log information with color, the site ID, the VPN label, if MPLS is there. You understand this now better?
Yes. Yes.
Okay. Now, OMP route advertisement. I told you this is making control plane dynamically built on all the edge device. So OMP route advertisement, type of information shared via this control plane OMP. First one is the route types. OMP routes, a standard IP prefix. I told you local site addresses will be advertised. That's route. That's standard IP prefix learned from local site. And the T-log routes information about the endpoints, the other sites, local site. That's one type of route. And then T-log route, which is nothing but the information about the transport endpoint. The third type of route is service route. Should I use IPS for inspecting the traffic before sending it out? Or if any traffic is coming inside, should I take it directly without a thorough check with the firewall, or it should go through the firewall? Those are all called as service chaining or service route. So when a traffic is coming from outside, edge device will say, hey, you go to the firewall. I have kept the firewall here. Go to the firewall. If firewall approves, you go inside the organization. That instruction is also what? Route. Where is that configured? On the vManage somewhere. But it got downloaded in the vEdge using OMP. So now edge router, without you configuring, edge router got this configuration saying if any traffic is coming from outside, before sending it inside, push it through the firewall. Make the traffic to go through the firewall. Give the next hop address as firewall address. Now, did you understand the types of route? T-log routes, service routes, and normal standard IP routes. Dynamic information. BFD status. What is that? If a link goes down, BFD will notify, which is nothing but the reachability. The health of the device and the interfaces, tunnel informations, all these are carried by BFD status. VPN context, which is now, what is context? Context is nothing but VRF. Traffic of one context will not disturb the other context. You know about VRF, right? Traffic of one VRF. No. That is what. Those information, dynamic informations are called as VPN context. Mapping the prefix to specific VRF. this traffic belongs to this customer. It should go through this VR, this VPN segment. So all these things are policy-based routing. These are all determined based on the configuration that you do in vManage. For that, you need to have a very good understanding of network. Only then you can put the configuration and vManage, and those things will be applied by OMP to the routers. See, these much thing that SD-WAN can do, but do we know this much thing to make use of this SD-WAN to work for us? That is a big question. So no one can come straight away to the software side of network and say, I became an engineer, I'm a good engineer. No, not at all possible. Someone should start from scratch, from CLI, as you're doing, as you have learned all the protocol for these many months systematically. Only then you can use this SD-WAN effectively. Next, do you